Alright, welcome to my channel. Alright, as you can see today we are going to cover chapter 4 about reactivity of metals. Alright, so let's get started. So first of all, what is the learning outcomes throughout this topic? So at the end of the chapter you should be able to A. To know and name the variety of minerals. B. To understand and know about reactivity series of metals. C. To understand and perform the experiment related. And D. To understand about how to do the extraction of metal from its ores. Alright, okay, so and then this is the subtopic 4.1 regarding variety of mineral. So what is a mineral? Alright, so mineral is actually a solid elements or compounds present naturally in a crystalline structure and with chemical composition usually found in an earth crust. Right, for the mineral we have two types, which is the element mineral and also compound mineral. Okay, this is a typo, sorry. So mineral elements basically consist of only one type of atom lah, which cannot be broken down into simpler substance or constituent element, okay, by chemical or physical means. For example, gold, silver, antimony, calcium, and etc. But on the other hand, the compound mineral is consists of two or more different elements that combine by a chemical means lah. Right, for example, bauxites, hematites, galena, cassiterite, and etc. Right. So later you will see bauxite is actually a combination of aluminium and some other elements. Right. So this is known as the elements. Okay, so this up one is the top one is the elements: gold, silver, antimony, calcium. But this the bottom one is actually the compound. Okay, so you can, this is compound, okay, compounds, and this is the elements. All right, so the compound is this, how they look like. All right. Okay, so compound and its element. So as I already said, compound is actually made up of several elements, two or more different elements. For example, hematite is basically made up of elements iron, okay, iron and oxygen. Right, you can see over here. And also cassiterite is actually the systematic name is tin 4 oxide. We call this tin 4 oxide, which is made of what? Made of tin and oxygen. So oxygen is O2, right? And quartz is made of silicon and oxygen. Bauxite, as I already said, bauxite is made of aluminium. So aluminium is Al, and also oxygen O2. Alright, sorry, O2. Okay, and this you can read by yourself, so I recommend you to memorize those that I tick over here. So for hematite, cassiterite, bauxite, and calcite, I recommend you to memorize, but better to memorize all lah if you can. Better to memorize all of them. And also the systematic name is also important, and also the combination of elements, right? So you can read over here is a science info, so this is the additional information for you. So basically a calcium carbonate is formed into several types. I mean, it is existing into several types such as limestone, marble, chalks, and also the calcites. So calcite is basically this lah, calcium carbonate. Okay, so limestone, marble, chalk, and calcite is basically calcium carbonate lah. Okay, calcium carbonate, right? Okay, let's see this. So this is the experiment from your textbook, page 1 to 6 till 1 to 7. So you can see basically this is the setup of apparatus, and this is the calcium carbonate, this is the hydrochloric acid, and this will produce the gas basically, and will be the gas will flow throughout this tube, and then the lime water will change its color after all. Okay, so this is the observation. So I already fill in some of the answers. So before the gas passes through, so the condition of the lime water basically colorless. So colorless means it's the natural or the original color of the lime water is colorless. Okay, it has no color like water. And also this also colorless, but after the gas passing through it, the lime water will turns cloudy with bubbles in it, right? And the question, name the gas involved, is basically carbon dioxide lah. So basically in this boiling tube, the carbon dioxide will be released, and then the carbon dioxide will flow throughout this tube and then will turn this lime water into cloudy and with bubbles. Alright, and I want you to answer the rest of the question 2, 3, 4 and 5. So I want you to find the reference. I don't care where you want to find the reference, either from the textbook, from the other textbook, or from the university textbook, or from the Google. It's up to you, but I want you to answer the rest of the questions. Alright, okay, next. Okay, let's turn into the next subtopic, which is the reactivity series of metals. So this is kind of interesting. Why? Because we are dealing with some more elements, important elements, and I will show you what I mean. Right, as you can see, reactivity of metals is actually defined as how strong or vigorous is the metal react with another substances or element. In our case is oxygen. So in our topic, or in the Kssm textbook, so the reactivity involved is actually reactivity within oxygen or reactivity with oxygen. Okay, so how strong or how vigorous the metal reacts with oxygen lah, basically. Okay, so reactivity of metals is subcategorized into two, which is vigorous reaction or fast reaction, and less vigorous or slow reaction. So vigorous reaction, for example, is the reaction between the calcium. So calcium is basically a mineral, and oxygen. So the reaction will fast. So the calcium solid will burn instantaneously in air, and same goes with the magnesium and water. When you have a magnesium and you put it into the water, it will explode and will produce fire or burn like this, right? So it's a very bright light due to the burning of the magnesium in water. On the other hand, the less vigorous reaction, for example, is the rusting. Of course, because when you see a metal, not a metal, iron or a steel, it will takes very long time to rust, right? It will takes very long time. And same goes with photosynthesis. And photosynthesis also processed by a plant to produce food, right? So this is actually takes time to be undergone, right? Okay, let me show you how the reaction of oxygen with calcium. So this is calcium with oxygen. So the reaction is very vigorous and very fast, right? So it will burn on air, in air, like that. And the second one is the magnesium with water. So you put the magnesium in water and then it will burns like this. Okay, you can see, right? So it's very fast, it's very instantaneous, it's very instant, right? Okay, next. Sorry. So this is the reactivity of metal. Sorry. As you can see, so reactivity of metals, reactivity series of metal with oxygen, right? So this is the reactivity series setup. So the reactivity series start with potassium with the symbol K, and then followed by sodium Na, calcium Ca, and finally gold. So the symbol for gold is not G, not G or GO. The symbol is Au. You need to remember the symbol. So this is the symbol, alright? Au, Ag, Hg is the symbol of the elements or the metal. So if you realize, so I close or I just ignore the element over here because I just close because it is not important for now. Later I will show you what I mean. But for now, you need to remember these K and A, Ca, Mg, Al, zinc, Fe, and also the name, the full name: potassium, sodium, calcium, magnesium, and aluminum. Okay, so from here, starting from gold, the reactivity is the weakest from gold, and then up to the top, the reactivity is the strongest or the most vigorous. So you can see the reactivity of metal towards oxygen increases from gold to potassium. Okay, so the way to memorize this, I have the acronym for this. So this is the acronym from my chemistry teacher during my form 4 and form 5. So he introduced me to this acronym, how to remember this series of reactivity. So this is the acronym. So kalau nak cantik mesti ada zebra Ferrari supaya cukup happy as you. Okay, supaya cukup happy as you. So how this works? So as you can see, the initial alphabet or the first alphabet reflects the symbol of the metal. So K for that, and A for that, Ca for that, and so on so forth. So the last one is Au. So Au is this A and U. Okay, so this is how you can understand it in a simple acronym word. Okay, so you can read over here, the top element metal is the most reactive. So potassium is the most reactive because it is on the top, and then the bottom element, which is the gold, okay, is the least reactive, is the most least reactive basically. So the second statement you can read, potassium will burn vigorously in air than sodium. Okay, so you can see, so potassium will burn vigorously in air than sodium. Why? Because potassium is located at the top of the reactivity series than the sodium. So sodium is below potassium, right? So of course potassium will more vigorously burn in air. And gold is the most least vigorous element to burn in air. Okay, so the brightness and the strength of the explosion due to burning tells you how vigorous the reaction is. So as you can see over here, so this is the reaction of magnesium with water, but this is because with air or with oxygen is over here lah. So you can see the burning of calcium in air produce a very light very bright light due to explosion, due to burning, and this indicates the reactivity of the calcium. Okay, so for example, the reaction of potassium will explode strongly and produce bright burning than sodium and calcium. Of course, the potassium will burns more brightly than sodium and calcium because potassium is located at the top of the sodium and calcium. Okay, like that. Okay, so position of carbon and hydrogen in reactivity series. Okay, so as you can see, I already reveal you the element that I closed this now, this one. So I already reveal it to you, which is carbon and hydrogen. So carbon and hydrogen. But how does the scientist or the chemist knows that the position of hydrogen is over there or the position of carbon is over there? So this is taken from your textbook, page 134. Okay, page 134 over here. Okay, so position of hydrogen in the reactivity series. So they did this kind of experiment in order to know where is the position of hydrogen. Okay, where is the position of hydrogen and carbon? For the case of hydrogen, you can see basically the mixture is burned into the, you can see, into this is burned here. So it is burned there, and then the element is put inside of the boiling tube, a test tube, and then will burn. Okay, For example, the first statement, hydrogen and aluminum oxide. So aluminum oxide does not glow. Aluminum oxide is white in color. What does it mean? It means that the hydrogen does not reduce the aluminum oxide. Okay. If that's so, which means that aluminum is more reactive than hydrogen. So hydrogen is H, which means the hydrogen should be below aluminum. It should be here, or it should be here, or it should be here. So we do not know yet. That's why we do the second test, which is the hydrogen and zinc oxide. So you can see hydrogen does not reduce the zinc oxide, which means the zinc more reactive than hydrogen. Okay, so zinc is more reactive, which means the position of the hydrogen should be below the zinc. It cannot be above zinc. It should be below. And then the third statement, you can read the third statement. The hydrogen and lead-2 oxide. So lead is produced, which means the hydrogen can reduce the lead lah. Maksudnya, which means the hydrogen should be on the top of the lead. So it should be here. Sorry, it should be here, or there. Okay. But we do not know yet. Yang kita we are very sure that the hydrogen is below the zinc lah, below the zinc. So these three options. And then the fourth experiment, or the fourth test, the fifth one is copper is produced. 1, 2, 3, 4, 5. Okay, so this is the fifth test. Hydrogen and copper. So copper is produced, which means the hydrogen can reduce the copper, which means the hydrogen should be on the top of the copper. So it should be here, there, and there. And then this should be the sixth column, which is the reaction between the iron oxide with hydrogen. So when the sixth test is done, then you will see that the hydrogen can reduce the iron oxide to produce the iron, which means that the hydrogen should be on the top of the iron, which means over here. Okay, so this textbook is not complete, I think, because it gives holistic description, not gives the complete description for this, but I give you the final test, which is the iron oxide with hydrogen, so that you are sure that the hydrogen is above the iron and also below the zinc, over here. Okay, above iron and below zinc. Okay, so that's how. And this kind of experiment can also be done to determine the position of the carbon, which is between aluminum and also between zinc, okay, like that. And then the third subtopic, which is 4.3, is the extraction of metals from its ores. So what is meant by extraction of metals? So it is the process of obtaining metal elements from their ores. So ores is basically the rocky element that you've seen in the previous slide, which is this. So this is actually the ores. So bauxite, hematite, galena, cassiterite, and also gold, silver, blah blah blah, is basically known as the ores. Okay, the rocky compound or elements found on the inside the earth crust. Okay, like that. So you can read, this is taken from your textbook. So the extraction through electrolysis of metallic compound in molten form is for the first elements in the reactivity series. So you can see the potassium, the sodium, calcium, magnesium, and aluminum, we need to do electrolysis in order to separate them from their ores, right? So we can use electrolysis. But for zinc, iron, tin, and lead, you need to use extraction throughout the reduction of metal, oxide, and carbon. So I think you don't have to know deeper about the reduction of metal, oxide, and carbon, because this will be covered in the Form 4 and Form 5 SPM chemistry. So the thing that you need to know is the method done is throughout the reduction of metals oxide by carbon. So which means in order to extract the zinc, iron, tin, and lead ores into its metal, you need to use carbon, so that carbon can reduce these ores into the elements. For example, zinc, iron, tin. Because the ores, if you understand what is ores, so this is ores. So this is, for example, this is aluminum ores. So aluminum ores. So aluminum ores is not 100% aluminum. It is not 100% aluminum. So ores means there is a mixture of aluminum, maybe 60%, and also there is a mixture of oxygen, maybe 40%. So this is the meaning of ores. So we need to extract these ores so that we want to get this aluminum only. We don't want this oxygen. So we need to separate the aluminum from the we need to separate these ores from oxygen so that we get this aluminum only. Okay, we need the pure one, the pure aluminum or the pure metals. So that's the meaning of ores. Okay, but for the copper, mercury, you need to extract using what? Direct heating. So you need to heat them so that you can separate from the ores, so that you can get the pure copper and also the mercury. But the last one is special because you don't have to do anything in order to get the pure metals, because this is, for example, this is the gold. Okay, gold is yellow, right? So for example, this is the gold ores. So the gold ores is actually 100% gold already. So there is no mixture of oxygen, there is no mixture of anything, any element rather than gold. So this is gold 100%. Why? Because gold and silver is actually located very down below the reactivity series, which means that silver and gold is very less reactive with other elements, which makes them special because they exist in the form of element or atom themselves. Okay, 100% element without any extraction of the metals, right? So I hope you understand. So this is the process. You can read by yourself. So the process uses 4 steps. So the first steps, you can read: a mixture of concentrated iron ores, coke. So coke is carbon, and limestone is added into the blast furnace from the top. So over here, so everything is mixture. So there are 3 mixture, which is the iron, so the coke or the carbon, and also the limestone is put from the top to the blast furnace. And then the second step is a very hot blast air is pumped. So you can see over beside here is a hot air being pumped into the blast furnace. And the third step is what? Is the production of iron occurs. So the production of iron, you can read over here. There are 3 steps. I mean a 3 statement over here. You can read: coke or carbon reacts with oxygen in the hot air to produce carbon dioxide and heat. So you can, this is the equation, but I don't recommend you to memorize the equation, because this is not your level to know or to understand the equation, because you are still in the Form 3. But you can practice for your next Form 4 and Form 5, because in chemistry you will find this if you enter the science class lah, of course. Okay, but I recommend you just to read and understand the statement only. And then the second statement is the carbon dioxide is produced to react with the rest of the hot coke to form carbon monoxide, which is strong reducing agent. And then the third statement is carbon monoxide and carbon reduces iron oxide into iron. Alright. And then the next one is the production of slag. Okay, later I will tell you what is slag. So limestone or calcium carbonate, you can read over here, decomposes to form calcium oxide and carbon dioxide. Alright. And the second one, calcium oxide reacts with impurities such as sand or silicon dioxide in iron ore to form slag or calcium silicate. Okay, so this is the three steps. And then the last one is the fourth step. Okay, so for air at high temperature, the iron will melt. The molten or the melted iron will flow to the bottom and allows to cool and solidify. So the iron will solidify, and then we can take the iron, okay, as it already cools down and solidified. Okay, so the solidified iron known as the cast iron. Okay, the 4B. The slag is produced will also melt, of course, because it is under the high temperature, right? Because this is very high temperature, so of course it will melt. But since the molten slag is less dense, it will float to the top. So the slag will eventually float over here. So this is the slag will float on the top of the furnace and is used to make the building or road base. Okay, so what is slag? What is slag? So slag is basically a stony waste product produced from the extraction of metal. So it's just a side product. Okay, in simple word, slag is just a side product or a byproduct which is not used in the extraction, or useless basically in the extraction of metal. Right, so this is the last sub-chapter, which is the mining issue in Malaysia. So you can see at the last subtopic in your textbook. So the several issues of mining in Malaysia is very basic and very common sense. Is air pollution, water pollution, soil erosion, sound pollution. So it's all about pollution, soil erosion, and also destruction of habitat of animal and plant. So if you do mining at the place which is the habitat of animals or plants, so basically you destroy their place to live, okay, just to do mining and just to mine the ores and also the metals from the earth crust. So this will cause destruction of habitat, and also the sound pollution, because in order to do the extraction you need to use the very gigantic and also very noisy machines to do this kind of activity. And also of course you will have soil erosion because you did mining, right? Because you dig down the earth crust, and this will cause the soil erosion when it comes to raining or so on, right? And also water pollution and air pollution. Of course air pollution because the machine itself operates using the fuel, and also the fuel will burn, and the burning of the fuel will produce very hazardous smoke, and then will be released outside the environment and can cause the air pollution, of course. Alright, so this is the end of the notes. So if you have anything to ask me, so feel free to ask me. Okay, you can ask me throughout WhatsApp, Telegram, or YouTube in this comment, and yeah, I will see you in the next video. Thank you.